In this video, we will have an introduction to linear equations in one variable. So a solution of an equation is a value of a variable that makes a true statement when substituted into the equation. So your solution or your answer, when you find an answer like x equals 2, when you substitute it back into the original equation, it should produce a true statement. How to determine whether a number is a solution of an equation? You're going to substitute in the value for the variable into the equation. You're going to simplify both sides of the equation and then decide if the resulting statement is true. If it's true, then it's a solution. If it's not true, then it's not a solution. So we have 3/5 that they want us to plug in for y. So we will have 5 times 3/5, or you could do parentheses, plus 3 is equal to 10 times 3/5 minus 4. So I'm going to cross reduce, so the 5's here divide out, and so that will leave me with 3 plus 3 is equal to, 5 goes into 10 twice, so 2 times 3 is 6 minus 4. 3 plus 3 is 6. 6 minus 4 is 2. You can see that that is a false statement. 6 is not equal to 2. So if you get a false statement, that means y is not 3/5. So that is not a solution. So you can say y is not 3/5, or you can say 3/5 is not a solution. So in order for it to be a solution, you would have to get a true statement. All right, so let's look at the next part. A linear equation in one variable is an equation in one variable that can be written where a and b are real numbers and a is not equal to 0 as ax plus b equals 0. So all that is just to kind of say you have one variable, so a and b are numbers. Your variable, in this case, is x. It could be any letter or any variable. Notice the x is not does not have an exponent on it. It's not like x squared, because then that would no longer be linear. That would be quadratic. It's just a plain x. There's no exponent on it. It's not under a radical. That is a linear equation, an x to the first power. To solve a linear equation, here's a general strategy. So if you like lists or step-by-step method, this is what you can use. And we can kind of highlight some of the key things. So step 1 is to simplify each side as much as possible before you do anything else. Step 2, collect variables on one side. Collect constants on the other side. So for example, I like my variables on the left and my constants on the right, but it doesn't matter as long as you take all the variables and put it on one side of the equal sign, and the numbers that do not have variables, constants, on the other side, you're good. Then you make the coefficient of the variable equal to 1, so that you just have x equals whatever it's equal to. You don't have to check. That's an optional step in this case. So let's do some examples. So in this one, we have negative 3x equals 9. The left-hand side is multiplication. It's negative 3 times x. To undo multiplication, you use division. So x equals negative 3. Number 3, we have y plus 21 equals 5. We have addition, what we want to undo, so we will undo that by subtracting 21 from both sides. Keep in mind when I say both sides, I mean both sides of the equal sign. So the equal sign creates a barrier, and you have to do the same thing to both sides of the barrier in order to keep the equation balanced. So for number 4, oh, number 3, I didn't even finish that. So if we subtract 21 from both sides, we get y equals negative 16. Okay, number 4. So first we want to look at each side of the equal sign. So on the left-hand side, I can see that I can simplify. So I can distribute the 15 and get 15z minus, let me check and see what 15 times 9 is. So that's 135 equals negative 60. Now that I've simplified the left-hand side, I can start trying to undo everything away from the z. So I would add 135 to both sides, and that would give me 15z equals, so 135 and a negative 60 gives me 75. So again, here's my line. So now I want to divide both sides by 15 to get the coefficient of z to be 1, and that would give me 1z equals 75 divided by 15 is 5, so z equals 5. Okay, number 5. On the left-hand side of the equation, we have this 2/3 that we need to distribute. So 2/3 times 3. So if you need to do side work, that's okay. So the 3's will cancel out and leave 1's. So this is just going to be 2. So we'll have 2m, and then we have 2/3 times 6. So the 3 will divide into 6, and that'll be a 2. So we'll have 4. So we have minus 4 equals 5 minus m. So now that we've simplified the left-hand side of the equation, we can move our x's to one side, or in this case our m's, and our constants to the other. So I'm going to move the m to the left by adding m so that it zeroes out on the right-hand side. 2m plus m is equal to 3m, and I'm going to bring everything else down. Now I want to move the constants to the right, so I'm trying to get everything away from the m. So I'm going to add 4. That'll give me 3m is equal to 9. And now I'm going to divide both sides by 3 to undo the multiplication, and that will give me m equals 3. So for any of these problems that we just did, you can always check your answer by plugging that number back in for the variable and simplifying each side and making sure that you get a true statement. It's not a requirement, but it is possible just for you to check in case you want to see if you're right. All right, so now they get a little bit more complicated. Number 6, we can distribute the 4 on the left-hand side. And on the right-hand side, we have a negative 7 to distribute. So let's do those two things. So we'll have negative 15 plus 8 minus 20y is equal to negative 7y plus 28 plus 4. So distributing the 4 times 2 is 8, and 4 times negative 5 gave us the negative 20y. And on the right-hand side, negative 7 times y is negative 7y, and negative 7 times negative 4 is positive 28. Now we want to continue to look at each side and see if we have like terms. So on the left-hand side, we have a negative 15 and a positive 8. So if we combine those together, we will get negative 7 minus 20y. And on the right-hand side, we have a 28 and a 4. Those are like terms, so we could combine those together, and we would get negative 7y plus 32. So now we want to move our y's to one side, so I'm going to move them to the left. So since I have a negative 7y and I want to zero that out, I'm going to add 7y to both sides. So that will give me a negative 7. Negative 20 plus 7 will give me negative 13y, and bring down the 32. I now want to move the negative 7 to the other side, so I'm going to do that by adding 7 to both sides. So I get negative 13y is equal to, That'll be 39. And then I need to undo the negative 13 times y. So I undo multiplication by division. And I will get y equals, whoops, it should be a negative 3, right? Positive divided by negative is a negative. So negative 3. Number 7. Again, we start with some distributing that needs to happen. So 15 times n is 15n. 15 times 2 is 30. So on the left, we will have 15n plus 30. 3 times 5n is 15n. And 3 times negative 4 is negative 12. So 15n minus 12 will be on the left. on the right. Now we want to move our n's. I'm going to move them to the left. So I'm going to subtract 15n from both sides. And notice what happens. They cancel here, which is what I wanted, but they also cancel on the left. They zero out on both sides. I have no n left anywhere. So on the left side, I have 30 equals. On the right side, I have negative 12. If all of your variables cancel out and you're left with a false statement, which this is false, 30 is not the same as negative 12. So this is false. You have no solution. So this equation has no solution. There's nothing that you can plug in to n to get a true statement. So no solution. Okay, number 8. We're going to start by distributing. 6 times 2n is 12n. 6 times negative 1 is negative 6. Plus 3 equals 2n minus 8. And then we're going to distribute the 5. 5 times 2n is 10n. And 5 times 1 is 5. Now we want to look on each side of the equal sign to find like terms. So we have negative 6 and a positive 3. So we'll have 12n minus 3 equals. On the right-hand side, we have a 2n and a 10n. So 2n plus 10n is 12n. And we also have a negative 8 and a positive 5. A negative 8 plus 5 is a negative 3. Okay, so again, I want to move my n's to the left. So I would start by subtracting 12n from both sides. And again, notice that they completely zero out on both sides of the equation. I have negative 3 on the left, and I have negative 3 on the right. This time, the difference between this one and the previous one is that this is actually true. Negative 3 is equal to negative 3. So if you get a true statement, you have infinitely many solutions. Or you can say all real numbers are a solution. So all real numbers are solutions to this equation. Any real number that you pick to plug in, it will work every single time. All right, number 9. Let's distribute the negative 2. So we have negative 22 plus 14x plus 54 equals 4. On the left-hand side, we have negative 22 and 54. Those are both constants, so we can combine those together. So negative 22 plus 54 is equal to 32. So we'll have 14x plus 32 is equal to 4. And now we want to get that 14x by itself. So we'll subtract 32 from both sides of the equal sign and get 14x equals 4 minus 32 is negative 28. Now we want to get the x by itself, so we'll divide by 14, and we'll get x equals negative 2.